Okay, hi all. My name is Karev. I'm a front-end developer at Yandex, and today I want to speak about client-side optimization for mobile devices. The things I want to talk are specifics of mobile web, optimization, and performance metrics. As all of you know, there are two main problems with mobile web: poor network conditions and a variety of devices. I will shortly discuss the first one and pay more attention to the second one. Now let's start with mobile network. The main thing you should keep in mind about mobile network is the round trip time. It means the time it means the ping time from the user devices to your server. And here's the distribution of the time for our mobile search servers. You see that for almost 30% of users, this time is more than 100 milliseconds. And for about 12%, it's more than 200 milliseconds. That's too much. And here's this distribution grouped by network conditions. And here you see that for 3G and beta networks, the 3G and beta networks are pretty good, but 2G network is terrible. So the main thing you have to keep in mind about mobile network is that network requests are expensive, and you need to avoid them. Unnecessary network requests, especially during the critical rendering path. So let's have a look to the current state of mobile devices. Here are the visits to mobile Yandex through page, and they're grouped by platform. And you see in the last August, in this August, we have about 1/3 iOS, 2/3 Androids, and just 7% of Win phones. And comparing with the last year, Android and iOS have grown for about 1%, and Win phones lost more than 2%. And there's no problem with iOS. Every year they release a new version, and almost all the user updates it during this year. But it's not so far easy with Android. Many people have phones that with an Android version that couldn't be updated. And for example, you see that the part of Android 5 haven't changed during this year. And we also have Android 6 and Android 7 that replace the default. And almost all WinPhone users have version 8.1, and its share goes on to decline. Here are the results of the distribution wars in the last year. Popular browsers are growing, old browsers are decreasing, as usual. And we have one beginner, new MIUI browser. Does anybody know it? Yeah, that's cool. During this year, it has almost risen to EA Mobile, and it's significant. In addition to all this, we have a lot of mobile vendors. Here are the top vendors that are ordered by the frequency of use. I think you don't know all of them. And you may guess there are a lot of low and middle and low class phones, and we have to keep it in mind. So let's talk about optimization in details. As I've already mentioned, network requests are expensive and takes much time. So it's really important to remove redirects. You need to use the same URL to handle both desktop and mobile requests. And if you use redirects for counting links, you need to use beacons. What are beacons? It's a special browser API that allows data to be sent asynchronously if the page was closed. And you shouldn't be afraid that requests can be aborted anytime when page is unloading. Beacons have pretty good supports in all browsers, and the cool thing that they are supported in Safari Technical Preview, and maybe will support it in mobile Safari in future. Several words about web fonts. All designers like web fonts, but unfortunately, we have an acceptable way to load them and at the same time to avoid the flash of invisible text. So we have to use some tricks for their loading now. For example, we did it in some our page. In the first page view, we use default font, and load fonts in background and set up a cookie. And for the next page visit, we check up this cookie, and if it exists, then we use custom font. The best practices of loading resources are inline CSS to the page and load scripts asynchronously using defer or async. And you also can increase the script load priority with link rel preload. It's also useful to check code coverage of your static files. And it can be easily done with coverage tab in developer tools. Did someone use it? Just 4? Oh my God. Okay, remember it. Now I'll tell you about some optimization we did with our mobile, Yandex mobile main page. First, we inline all the CSS code to the page, but we split this code between all the blocks, and not as a single part in the head. So we need styles for news, and then HTML for news, styles for TV block, and then HTML for TV block, and so on. In our page, we have many tabs in our news and TV blocks, but we need to show only the first tab during the first page view. So we begin to load their content asynchronously in background when user starts interacting with the page. But we have to be very careful here, because user can click the tab contents before it contents was downloaded, so we can miss these clicks. Another great thing we did is a separate suggest script. It contains all necessary functionality for the search suggest, but has no dependencies and has the size of only 14 kilobytes. And we can download it before the main script to make search suggest be available faster. We also did several optimization with our ya.ru page. Sometimes to do it well, the only way to do it well is to remove old code and write a new one. So we did it this way. We write a new version with JavaScript, with no dependencies of JavaScript library, and came to an optimal script loads order. I'll tell you about it a little bit later. And we'll also use service workers and cache all the page and all its resources. So what is the optimal scripts load order? In browser with defer support, you should load the script with defer before the inline CSS in the head. But in iOS, you should use async instead of defer. And for UC browser, it's better to use dynamic script tag instead of async or defer. And for all other browsers, you should load the scripts after the content in the end of the body. Another way for mobile optimization is to create a special page for slow connection. And we did it for our mobile search result page. Again, it was a new version without legacy. It contains all the main features, but has no dependencies on any JavaScript libraries, and has the response size of only 10 kilobytes. Here you can read about it. And now it's available for about 8% of our mobile traffic. Now let's talk about performance metric to control all our optimizations. In the last Google I/O, there was a great speech about how to operate performance metrics. I really advise you to read this article. The point is we need to measure user experience, and we need to find appropriate metrics to do it. What experience we need to measure? They suggest the following. Is something happened on page? Is it useful? Is it usable? And is it delightful? It's better to see it in the timeline. There's nothing at the beginning. Then something was painted. After that, something meaningful was painted. And at last, the page became usable, became ready for interactive. So let's start with first two metrics, first paint and first contentful paint. Measuring the first paint is a long and big story, and actually we were able to measure it for the last several years with Chrome load times function, and here's an example of code doing that. Did someone use it in your projects? Nobody? Oh, okay, I saw 3 people. Yeah, okay. But now, since Chrome 16, we eventually have a right way to measure it with new paint timing API. All this year, Chromium developers claim that it's really hard to implement it, but finally we've done it. So it was really interesting to compare our old first paint with new first paint. And here are the distribution of these 3 metrics for our page. Old first paint, new first paint, and new first contentful paint. You see for our page, they are equal. So it's good, it's because our old metrics was right. But you can get another results for your pages. Let's go on the next metric, first meaningful paint. There's no common approach to measure it because it depends on the page. You as a developer have a better understanding of what is the most important element on your page, or hero element. And for client-side rendering, you can measure its time when you add in the content to the DOM node. And for the server-side rendering, you can use intersection observer API. This is a special API that allows you to understand the visibility and position of DOM elements. It can be used for as visibility counters, for example, or for implementing scrolling content. And you can also use it for any DOM element, on the page that you identify as a main element. And it has pretty good browser support, but except Safari again. Now I want to talk about the last thing, the time to interactive. In the article I've mentioned before, it's defined as the time after the 5 seconds of zero network activity and 5 seconds from the last long task. In our page, we have a lot of requests and backgrounds, so we used only the time from the last long task. So we collect all these metrics, and here are the distribution for our page. It seems well right. First paint comes first. After that, we have, after our hero element is shown, the search arrow. And after that, we have DOM content loaded event and time to interaction event. It's great. So let's understand what are the long tasks I was talking about. The long tasks are the parts of JavaScript codes that are executed for more than 50 milliseconds on your page. And you can easily find them in the performance tab in developer tools. Just click in the different pieces and check their time. And the great thing that we can get all of them from the user's page with LongTask API. We're able to get the name, the start time, duration, and some attributes describing them. So let's do it. What's what we've got? This page represents the time when long task appears on the page, and they are grouped by their name. And most of these tasks are self-tasks. So this is because it's happened because of our JavaScript on the page. So let's combine them all together. This is a very convenient illustration of what's going on with your page. And it's very nice to have this illustration to evaluate your experiments. You can get one experimental group, one control group, and compare it and make decisions. Indeed, we have one more important question. We need to understand of how much time it takes for your JavaScript to execute on the user devices. And here's the distribution of the time for two scripts on our page. One orange is the little suggest scripts of about 14 kilobytes, and one blue one is the main JavaScript code with about 90 kilobytes size. So you see that for almost all devices, it takes more than 100 milliseconds to execute the first one, and 100 or 200 or 300 milliseconds to execute the second one. It's a big difference. And we can also use LongTask API if we want to know of how much time the main browser thread was blocked that brings flags to the page. We just need to summarize all the LongTask events to do that. And here's the distribution of this time for our page. You see that for about 80% of devices, the main thread is blocked for more than 1 second. Just think about it. And the main thing I want you to remember is that JavaScript runs very slow on real device. And you can easily make sure. Just open developer tools on real device and check the time that it takes to execute the JavaScript code of the same parts. And in this example, we have 140 milliseconds on workstation and 440 milliseconds for the real device. And that was quite expensive device, about $500. So that is my advice. Buy an expensive phone and use developer tools on it. Be closer to users. That's all. Here are my contacts. Thanks for attention. Any questions?
Thanks for your talk. What can you tell about using Google's Lighthouse for measuring PWA's performance?
Google's
Lighthouse.
I think I noticed one Google
Lighthouse.
It's something like page speed inside?
Yes, but it's targeted at PWAs.
I think I don't know.
Progressive web applications. It can measure first paint, first meaningful paint, right out of the box?
I don't know well these new tools. It was grown from the page speed inside. I think, yes.
Вань,
I understand.
Ваня, you may know it by the name of Audit tab in Google Chrome tools.
Yeah, it's the same thing. It's about a different name. So it's a really good tool, and you need to use it anytime you can. So that's all.
Thank you for the talk. I heard that now there is a proposal to JavaScript, JavaScript binary tree, that JavaScript is interpreted on the server and delivered to the device in interpreted way. How do you think it will increase the performance?
I think it will increase performance, but let's measure it. Just it's a simple question. We need to accept all experiments where they are compared with the old one. So it's pretty easy.
Once again, a couple of months ago, there was a library introduced that like pre-executes JavaScript code in some way. Have you used it? And
Optimized JS?
Maybe.
Oh yeah, we know it. We use it when we have some experiments and we have some funny results. I can explain you about it later. Yes, we have an approach.
May you explain what it does, in essence?
It depends on your project. We have a pretty big project with Yandex mobile page and have a lot of resources with different hacks. But one thing I remember is we had increasing and decreasing DOM content loaded time for about 2,000 milliseconds on the 9th percentile of just adding or removing 2 brackets. That's all. We need a callback for the loading of we load first script when we subscribe for the loading, and then after execute the main code. And if we add brackets of the code of the main code execution, the browser needs some additional time for evaluating it. If we edit or remove it, I don't. We will talk about later. So it has an really. So you can try to use it, but you need to measure the results in your project.
Hello, Ivan.
Okay.
Thank you for your speech. And I know that Chrome Web Dev Tools has process throttling, and why don't we use why we should buy some phone to measure some performance and don't just throttle processor in dev tools?
What the throttle decretion you want to use? 2 times slower, 5 times slower. Do you remember what is the real situation, or do you know what is the real situation?
Okay.
It's just one example, and if you measure its time on the all user device, you have full context. Mm-hmm. So you can use it, but when you use it on real device, it's more efficient, I think.
Okay, thank you.
No more questions? Thank you, Ivan. We will have a break. We will have a